Hey, this is our first video in our fractions series, and there's not a lot of prerequisites for this one. In this one, I want you to be able to use our number system and recognize some common units like grams, liters, meters, and at the end of this video, you should be able to understand some common vocabulary that we use when we're talking about fractions, hopefully be able to estimate the value of some fractions, and then recognize fractions and ratios and percentages. So we see fractions in a lot of different ways. In your math class, you might just see a fraction as nothing but a fraction, 7/10. In our science class, in our regular life, if there's a unit with it, we might see it as a measurement. Percentages are also fractions because this is 70% is telling us I have 70 out of 100. That 100% is the whole thing. So that one's also fraction, even though it doesn't necessarily look like it. And really, anytime you see a math problem that has division, that could be thought of as a fraction. The line in a fraction just means divide. So in the same way that 7 divided by 10 could be thought of as a fraction, the fraction 7/10 could be thought of as 7 divided by 10, either way. Decimals are even fractions. If you think about our place value system, each of these, since we have a base 10 system, are going to be different powers of 10, right? So we have tenths, hundredths, thousandths, etc. So this 7 right here is in the tenths place. So this is really 7/10 again. Even whole numbers are fractions. We don't usually talk about them as fractions, but 3 means I have 3 whole things, whatever my unit is. And so I can put that as 3 over 1. Any whole number, really, I can put over 1. I can make that denominator 1. So a ratio is also a fraction. And we might see these more often in, for example, cooking, things like that. Let's think about like maybe this was 7 cups of flour for every 3 cups of sugar, right? And if we imagine for a minute that those are our only dry ingredients going into this, whatever this recipe is, that has 7 cups of flour and 3 cups of sugar in it. If I wanted to take that ratio and make it into a fraction, and I'm looking at how much flour is in my dry ingredients, I've got 7 of my cups. But then remember that the bottom of this fraction, if I'm taking this ratio and making it a fraction, it needs to be how much I have all together. Like out of these dry ingredients, I have 7 of how much of it is flour. And on the bottom of my fraction, I need the total, my whole amount of dry ingredients. So I need to add those 2 parts together to get my denominator. And we'll talk more about those terms like denominator in just a second. But that's just a side note that if you have a ratio, this doesn't just turn into 7 divided by 3. This is saying I have 7 parts of one thing, 3 parts of another thing. So my total is going to be having to add those 2 parts together. I know a lot of students get nervous when they see fractions, maybe immediately shut down that they are bad at fractions and don't know what to do with fractions. The most important thing to remember is that it's just a math problem. It's just something divided by something. It doesn't have to be something that stops us in our tracks. We want to get more comfortable with using fractions. So a fraction is just one way that we're depicting some amount. 10 could be an amount, but also 4 could be an amount, and a half can be an amount. And here we're going to talk about 7/10 of a liter. That's going to be our amount. So the denominator, the bottom part of this fraction, tells us the parts of the whole. Here, our whole unit is in liters because we're measuring in liters. And since we have a 10 in the bottom, that means that each liter is divided into 10 equal parts, or one of those parts is just 1/10. The numerator, that's the top part of my fraction, tells us how many parts we have, right? So the denominator told us how big those parts were, and now the numerator tells us how many we have. In 7/10, that means I have 7 of these parts. Here's a picture where each of these pieces is 1/10, and 7 of them are colored in. Here's my, 1 liter flask. And if it was filled in right to the 700 spot, that would be 7/10 full, assuming that here is full, not all the way to the top. So in order to help you get a little bit more comfortable with fractions, I want you to first think about some fractions that you could picture, like half. Maybe you could picture half of a circle or half of a bar. These are some ways we show fractions. Or maybe you're just thinking about, like if your coffee was half full, how much of that coffee you would have. Those are all good options. Picturing a half. Maybe it's easy for you to picture quarters, because we use quarter coins in money. So you're picturing 1/4, 2/4, 3/4. But picture some that are easy for you. Maybe you're even a person who like a third is easy to imagine. Excellent. Picture whatever feels easy to you. Now, I'm going to show you some fractions, and every time, all I want you to think about is this closer to 0 or 1/2 or 1? And if it's close to 1, that means it's full, right? Whatever my unit is, we have almost all of it. If it's close to 0, that means I have whatever my unit is, I have almost none of it. And then half is, somewhere close to half full, okay? Or half empty, either way you want to think about it. All right, let's take a look. So just think about what 9/10 of a liter looks like. Do you think that's closer to a whole liter filled up, closer to empty, or closer to about halfway full? And 9/10, if I cut this into 10 equal pieces, 9/10 is going to be pretty full. So I think that is closest to 1. How about 1/6? Is this going to be closer to 0, half, or 1? 1/6, smaller than a third. It's about this much. Do you think that's closer to 0 or closer to half? I'm going to say that's closer to 0 because half would be if all 3 of these were filled in. So I think that one between 0 and 1/2 and 1, I think that's closest to 0. 7/9. Now, a ninth might not be something you can easily imagine, but again, is this closer to 0 or 1/2 or 1? I know that if I had 9/9, it would be all the way filled up, right? And I can also use what half would be to help me picture what half is. So if I had 1/2 a ninth, like what's half of 9? It's about 4.5. So if I had 1/2 turned into ninths, I would have to have like 4.5 of these pieces for it to be close to half, and I have 7 of them. So I'm saying, is 7 closer to 4.5 or is it closer to 9? And, you can make your judgment about that. But for me, I think this is closer to 1. It's closer to totally full than it is to only half full. I suppose it depends on how optimistic you're feeling that day. How about 18/40? Now this, again, a 40th is not something we come into contact with on a normal day, but think about what this might mean, closer to 0 or 1/2 or 1. Again, if I'm thinking about like halfway, if this is 40/40, and halfway is going to be half of 40, which is 20. 20/40. Where's 18 going to fall if this was 0/40? 18 is going to be like, I don't know, here-ish? I would say that's close to half, right? 2/15. Close to 0, close to 1/2, or close to 1? I'm going to say that is closest to 0. Again, we've got 15/15 out here and 0/15 out here. In the middle, we have whatever half of 15 is, 7.5. To do that, we can just divide 15 by 2 to find that number, right? If we have just 2, I think we're down here. That's like mostly empty. If I had a cake, I cut it into 15 pieces, and now there's only 2 left, I have not very much cake. I don't have almost or nearly half a cake. There's not that much cake left. And then 15/20. Where do you think that is going to fall? Here's 20/20ths. Halfway full would be 10/20ths. Hopefully you've already figured out my trick. 15 is right in the middle. It's exactly between 1/2 and 1. Okay, so before we get on to really solving fractions and converting fractions, for now we're just going to estimate, just like we did on those last few ones. We're going to use that same trick, really. Is it closer to 0 or 1/2 or 1? But like, we can use other numbers. We don't have to use just those fractions. So if I use a fraction to compare with that you are not comfortable with, remember, you don't have to be able to do this right now. We're practicing this. And as we go on, you may find that more of these fractions are easy for you. So if we were trying to do the value of 2/5 and we don't know much about that, we can compare it to 2/4. So remember I said that the denominator tells us how big the pieces are, but a bigger number doesn't mean bigger pieces. This tells us how many times it's cut into equal pieces. So in 2/5 we have 5 equal pieces, and in 2/4 I have 4 equal pieces. So if you think about a cake maybe that you cut into just 4 big pieces versus a cake that you cut into 5 pieces, a fourth of that cake is going to be bigger than a fifth of that cake, right? And on the top here, in both of these, we have the same numerator. They're both 2. So without having to draw this picture, although I do love a good picture, we can know that we have the same number of pieces, but these are smaller pieces. So 2/5 is definitely smaller than 2/4, or you can think of that as 2/4. If you know in your head right now how much money you would have if you were holding 2/4, then you know that 2/5 is less than 50 cents or half of a dollar, right? So 2/5 is less than a half. Excellent. We have estimated that value. And now, what if we have a crazy fraction like this guy? 65/68. So this is 65/68, I guess. So when we have that, and we're trying to compare to figure out what this is, you might not have a ton of, you're not familiar with like what a 70th looks like or a 64th looks like. I'm not, but there is a fraction I know, and I know well, that I can use to compare. And it is 68/68. I know exactly what that is, because remember, this line in a fraction means divide. So this is saying, what is 68 divided by 68? Or if you cut your whole into 68 pieces and then you took all of those pieces, how much do you have? You have the whole thing. So this is really a big invisible 1, this 68/68. Now in this one, I have the same size pieces because these have equal denominators. So I have the same size pieces, but I have different numerators. And remember, my numerator tells me how many of those pieces I have. So if I'm comparing, apples to apples, 68ths to 68ths, and in one fraction I have 65 of them, and in the other I have 68, and I know for sure 65/68 has to be smaller than 1. Not a lot smaller though, only a little bit. So here's a couple more we're going to practice with. I've got some unknown fractions and try to come up with something that's kind of similar to it, changing either the numerator a little or changing the denominator a little to kind of see what I'm thinking. So here on this first one, I have 23/99, which I just don't know anything about that. But we do use a base 10 system, which means tenths and hundredths and thousands are all pretty easy decimals. So I am going to put here that we could compare this to 23/100. Now 100 is a bigger denominator, which means smaller pieces. So if the pieces are smaller, but I still have 23 of them, then 23 99ths has to be a little bit bigger than 23 100ths. And I'm literally going to say that. Little bit bigger than, and 23 100ths, remember a penny is a 100th. How many cents would you have if you had 23? It's a little bit bigger than 23 cents, or 0.23. Oh boy, here I've got 5 over 2, or 5 halves. I am going to change my numerator this time to be 6 halves. And remembering that that line in a fraction just means divide, I do know what 6 divided by 2 is. It's 3. Here we had the same denominator. A bigger numerator means more pieces, so this guy's bigger. So 5 halves is less than 3. Has to be smaller than 6 halves. All right, 3 20ths. I'm going to compare this to 1 20th. And the reason I'm going to do that is, if you're using, American coins, you have a nickel. A nickel is 5 cents, and you need 20 of them to make $1. So this is the same as a nickel. Yeah? I have 3 nickels. I might actually be able to say this exactly. I'm going to say this is really exactly 15.15, because I have 3 nickels, 15 cents. Or I could also just say more than 0.05 if I don't want to do that precision of nickels. Yeah. All right, here we are with 6 fifths. And I'm going to compare that one, changing just the numerator to 5 fifths. I know what that is. That's just a big old 1. 5 divided by 5 is 1. Now we had a smaller numerator, but the same size pieces, right? 5 on the bottom. So we have fewer pieces. So 6 fifths is a little bit bigger than 1. I mean, you could even say it's 1/5 more than 1. But that's getting precise. That's not what we're here for today. All right, 19 40ths. I'm going to compare this guy to 20 40ths. I've been doing a lot of changing the numerator, but it has been helping. If I did that one, I know that 20 is half of 40. So this is about a half. But this is bigger, and 19 40ths is smaller than 20 40ths. So it's a bit less than a half. Now, if it's not easy for you to notice that 20 40ths is a half, that's okay. We have not yet done converting fractions and equivalent fractions. That is me using my comfort with 20 40ths. And so that one is a little bit different maybe than what you're going to be comfortable with quite yet, but that's okay. That's okay. We're just getting used to it. All right. So before we go, some important vocabulary. You saw some improper fractions in that last one where the numerator is larger than the denominator. We had 6 fifths and we had 5 halves. Anytime the numerator is bigger than the denominator, that's an improper fraction. And also, if it's positive, then we know it's always greater than 1. We have more than a whole thing. In a positive proper fraction, it's always going to be stuck between 0 and 1 if it's a proper fraction and it's positive. And then mixed numbers always have whole number parts and proper fraction parts. So you might have like 3 1/2. This is my whole number, and here's my fraction part. Mixed numbers are not typically written as a whole number and then an improper fraction. We would have to rewrite this. And we will learn to do that, but not quite yet. Now, obviously, this isn't what I want you to do, because I love fractions, but I am going to show you how to make them into not fractions. So If you started with 4/5 and you did not want that to be a fraction, remember, this is just 4 divided by 5. And you can put that in your calculator and get a number, and you're going to have 0.8, which is your decimal. If you wanted to take that decimal and turn it into a percentage, percent is always out of 100. So you can times that by 100%. 100% is just 1, so that's not changing the value. And now we have 80%. These are still equivalent to our original fraction of 4/5, but now we have them turned into decimals and percents. So if either of those are more comfortable for you, you're allowed to do them. I want you to feel comfortable with fractions.